Welcome to a LeanStacks instructional video. This video is part of the Spring Boot series. In this video, we build upon the Greeting Web Services project, adding local cache support to business services. Let's get started. I have opened the sample Spring Boot application in the Spring Tool Suite. Open the application class. This is the main configuration class for the application. Add the Enable Caching annotation to the application class. This informs Spring to enable cache management support within the application and search the codebase for methods annotated with cache management metadata. Next, we need to define a Cache Manager implementation bean. Spring uses the Cache Manager to store cached objects. For now, let's use Spring's Concurrent Map Cache Manager class. This is a simple, in-memory cache manager, which is great for non-production environments or proof-of-concept projects. Later, we will replace Concurrent Map Cache Manager with a Guava Cache Manager class. The Guava implementation is more robust and better suited for production environments. The Cache Manager constructor accepts an array of strings which signify the individual named caches controlled by the manager. Now that the Cache Manager bean is defined, we can annotate methods with caching instructions. Open the Greeting Service bean. Add the cacheable annotation to the find_one method. The value element indicates which cache stores the method responses. The key element defines the index value for the cached object. This annotation ensures that responses from the find_one method are stored in the cache named greetings and are indexed by the value of the ID method parameter. The cache put annotation is used to add items to the cache or update items already cached. Annotate the create method with cache put. The value element specifies the cache to use. The key element defines the index value to use when caching the method response. The key value uses the result keyword. In this case, the greeting returned by the create method is stored into the cache and indexed by the ID attribute of the returned greeting. Now, let's annotate the update method with cache put. This annotation is almost identical to the cache put annotation on the create method. However, the key element specifies the cache index value will be derived from the ID attribute of the greeting method parameter. The greeting returned by the update method is stored into the cache and indexed by the ID attribute of the greeting method parameter. If a greeting was already stored in the cache indexed by this key value, it is replaced by the greeting returned from the update method. Otherwise, the greeting returned by the update method is inserted into the cache. The cache evict annotation is used to remove cached items. Annotate the delete method with cache evict. The value element specifies the cache to use. The key element indicates that the cache index is derived from the ID method parameter. When the delete method completes successfully, that is, without throwing an exception, the greeting is removed from the cache. In many applications, it is desirable to create a mechanism to purge all cached items. The cache evict annotation has an element named allEntries to facilitate this. Let's create a new method named evict cache. The method has an empty body. It serves only as a location for the cache evict annotation with the allEntries element set to true. When the evict cache method is invoked, all items in the greeting cache will be purged. Let's run the application and see our hard work in action. Open a terminal window and change directory to the project base directory. Type mvn Spring Boot Run to start the embedded Apache Tomcat server on port 8080. I'm going to open my RESTful web service client and test the greeting web services. I expect to see the same responses since I've not altered business logic. I have added logging statements at the entry and exit of each web service controller method to show an approximate elapsed time for each service call. First, I'll test finding all greetings. This method's response is not cached, so I expect the behavior to be unchanged. Next, let's find a single greeting. This method is annotated with cacheable. I expect the result of each method call to be cached after its first invocation. Therefore, we should see a significantly faster response time the second and subsequent calls for the same greeting. Next, I'll create a new greeting. It has primary key identifier number 3. The cache put annotation instructs Spring to place the created greeting into the cache. Notice how fast the response time is when I retrieve the greeting we just created. This is because it was returned from the cache rather than the database. Now I'm going to update a greeting. The cache put annotation ensures that this greeting is updated in the cache, preventing stale results from being returned by the finder method. The subsequent request to find the updated greeting returns the correct information from the cache. Finally, I'll delete a greeting. The cache evict annotation removes the greeting from the cache. This ensures that calls to the Finder web service for this greeting do not return a cached greeting. They return not found, as expected. The Concurrent Map Cache Manager is suitable for non-production environments or proof of concepts, but for production environments a more robust implementation using EHCache or Guava is recommended. Remember too that these solutions provide a local cache and not a distributed one. If your application is hosted on multiple nodes, you may need to use a distributed cache solution such as Elasticache. Let's update the application to use Guava. First, add Google Guava and Spring Context support to the POM file. The Guava Cache Manager requires these additional dependencies. Next, modify the Cache Manager bean declaration in the application class. Replace the Concurrent Map Cache Manager class with Guava Cache Manager. You may supply additional configuration to the Guava Cache Manager here in the bean declaration method. Let's run the application once again. The behavior should be the same. We've simply changed the Cache Manager implementation. I hope you've enjoyed this video. Subscribe to the LeanStacks YouTube channel to receive updates as new videos are published. As always, you can find more information on LeanStacks.com.